let's solve exponential equations with logarithms. Now remember that exponential functions and logarithmic functions are inverses, which means they undo each other. That's why we can use them to solve the opposite equation, if you will. So first, let's remember our definition of logarithms. So if b to the y equals x, then y equals the log of x base b. This is helpful. That way we know if we're trying to solve an equation, we can use the opposite, right? If we're trying to solve an exponential, we can use a logarithm by rearranging based on our definition. So let's solve for x and round to 4 decimal places. I've got 4 to the x equals 7. Now, when we're looking at this, we're trying to solve for the variable in the exponent. And perhaps you're saying, well, if it's an exponential, I can just set the bases equal and then it's pretty easy, then I just solve. And yeah, that's great. However, look at your bases. If you got 4 and 7, you can't change anything, right? Nothing squared is going to give you 7, right? These are just ugly numbers. And therefore, we need to use a logarithm. So, math is about equality. Whatever you do to one side, you have to do to the other. So if I like to say we logarize, but that's not really a thing. So we're going to log both sides. And so that we can use the identity property, we're going to make it a base 4. And you might say, why are we doing that? Well, remember, by the identity property, the log of 4 base 4 is equal to 1. And so we are just left with the exponent. So by the power property of exponents, it would come out front, and then we'd have x times 1, which is just x. So x equals the log of 7 base 4. And you might be saying, I don't know how that helps me at all. Because your calculator, to calculate logs, calculates common logs, which is the log base 10. So we are going to use what's called the change of base formula. So the log of 7 base 4 is the same as the log of 7 divided by the log of 4 when you're talking in base 10. So when you're plugging this in your calculator, you want to make sure that the 4 and the 7 are both in parentheses. So log of 7, parentheses, then your division sign, log of 4. And you should get 1.403677461, goes on and on and on. We want to go to 4 decimal places, 1, 2, 3, 4. I look at the 7, 7 rounds up. So 1.4037, and that is the value of x. And if you're wondering, is that correct? Well, plug it in. If you go to your calculator and you type in 4 raised to the 1.4037, do you get approximately 7? If so, then you're correct. Okay? All right, let's do another one. 3 to the 2x plus 1 minus 6 equals 14. By the way, I'm going to do 4 examples. At any point in time, if you feel like you understand, go ahead and stop the video and move on. But if you need more examples, I'm going to do plenty because sometimes more helps. Okay, so when we are solving an exponential here, we need to isolate the exponential piece, which means I need to add 6 to both sides first. So 3 raised to the 2x plus 1 gives me 20. Now we're looking again, I've got a 3, I have a 20. There is nothing I can use to have the same base. So I'm going to apply the log to both sides. So log of 3 to the 2x plus 1 equals log of 20. But what base do I want to be in? Well, because my argument of my logarithm with the exponential is a 3, I want to be base 3. Okay? Because again, by the identity property, this piece kind of goes away, and I'm left with 2x plus 1 equals the log of 20 base 3. Now you want to make sure that you're not rounding too soon. So we are going to say, okay, I know my next step is to subtract 1. So I'll have 2x equals the log of 20 base 3 minus 1. And then the final step is to divide both sides by 2. Okay, so x equals the log of 20 base 3 minus 1, all divided by 2. Okay, so think this through in your calculator. You need to first take your log. So log of 20 divided by the log of 3. Right? This is your first step. So you do that. And when you type in log of 20 divided by the log of 3, you get 2.726833, right? Okay, so that equals 2.72, blah, 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 blah. But your next step after that is to subtract 1. Okay, so now I get 1.7268, blah, 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 divided by 2. Last step, so x equals 0.8634, rounded to 4 decimal places. So what I have up here in red, this piece up here, log of 20 base 3 minus 1 divided by 2, that's your answer. But if you need to round to 4 decimal places, you're going to need to actually do the steps, right? Use the change of base formula to find your log, then subtract 1, then divide by 2, step by step. Let's do another one. Solve for x, round to 4 decimal places. Our exponential is already isolated on the left, so I am ready to apply the log to both sides. And what base do I need? Base 7, because that is where the exponential is. So whatever piece has the exponential, that's the base you're going to use. So I have x plus 4 equals the log of 22 base 7. My last step is to subtract 4. So x equals the log of 22 base 7 minus 4. So again, we need to say log of 22 divided by the log of 7, change of base, then subtract 4. So when I type in log of 22 divided by the log of 7, I'm going to get approximately 2.4115, blah, 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 blah. And then I'm subtracting 4, because that's the second piece. Nope, that's not right. Hold on. I just wrote down the answer. Okay, when you do log of 22 divided by the log of 7, you get 1.5884, goes on and on and on. Then we have to subtract 4, because that's the second piece. So when you subtract 4, your final piece, that's when you get negative 2.4115, rounded to 1 decimal place. 4 decimal places. And the last one, solve for x, round to 4 decimal places. Okay, so again, the exponential is already isolated on the left, so we're going to log both sides. Now notice this one. The base of the exponential side is base 10. That's a common log. That's what my calculator is already in. So this equals x minus 1 equals log of 46. Last step is to add 1. So x equals the log of 46 plus 1. So I don't have to use the change of base. I can simply type in log 46, and that's going to give me a 1.6627, goes on and on and on, plus 1. So rounded to 4 decimal places, I get 2.6628. And that is solving exponentials with logarithms.